Today I'm going to just do a quick lesson on Lewis dot diagrams. So you guys learned how to do Bohr diagrams. So there's Bohr-Rutherford diagrams or Bohr diagrams. So we'll use oxygen as our example. So oxygen has the atomic level 8, so 8p, 8n, and it has 2 electrons and then 6. Okay, so that is a Bohr diagram for the thing. Sometimes you will have the full circles. I prefer just putting them like that. Okay, so now Lewis dot, you would have your oxygen. Now, when you look at diagrams and elements, what you want to have is the Lewis dot diagrams only focus on the valence electrons. Now, everybody knows what valence means. Okay, so valence shells, it's your outermost layer. So if you remember correct, we have your first ring, there's 2. Your second ring has the possibility for 8. Your third ring, another 8. And then after that, it goes to 18. Okay? So the valence shell or the valence electrons is always going to be your outer shell. Okay? So oxygen has 6 valence electrons. So to represent oxygen in a Lewis dot diagram, what you're going to do is you start at the top. It doesn't matter where you put them, but the only rule is they need to be an imaginary square. Okay, so you need them at the 12, the 3, the 6, and the 9 o'clock position. Okay, I hope my camera's getting that. And you would draw, so right now I start at the top, 1, 2, 3, 4. Okay, now I will go here, here, and that's it. Okay, so that's 6. So rather than make it like that, I could go here, and you keep it symmetrical. It doesn't matter. The reason we use these dots is for when you make covalent bonds. When we start to draw these Lewis dot diagrams and show bonding between pairs, it shows the relationship between the valence electrons. Okay? So if we take hydrogen, for example, hydrogen is a non-metal. Okay? Its atomic number is 1. So H1. Okay? So that means what? There's 1 proton, which means there's 1 electron. So if we did a Lewis dot diagram for hydrogen, it would be H, and there would be 1 dot. Okay? Now, do I put it there? No, I wouldn't put that one there. I would put it to the side. Because if you're going to show a bond with anything else, you're going to put the bond here if it's just 2 molecules. If there's 4 molecules, then you're going to have the one in the middle and the 4 going around. And as you go through them, you'll see them and you will learn more how to do it. Okay? So hydrogen is 1. Now, if hydrogen's going to form a covalent bond and make water, it would be H2O. Okay? So let's forget oxygen for right now, and let's just do H2. 2 particles of hydrogen. Okay? So if I have hydrogen here in a Lewis dot and 1, okay, now these dots can be erased and be represented by a line. So that means this one and this one come together, and how many electrons do they want in their valence shell? They combine so that they fill their shell. They want to have a full octet or a full outer valence shell. So this guy has 1. To get a full shell, he needs another 1. where's he going to get from? He's going to share it with this one. Okay? So now they each share, so they both have a full valence shell. Okay? So if we were to do H2O, hydrogen, oxygen, oxygen we know has 6. Hydrogen each has 1. Okay? So now these can be represented by a line, because you know that this is really like this. So now hydrogen has 2 in his shell, oxygen has 8 because he's getting 1 from this molecule of hydrogen, 1 from this molecule of hydrogen. So now if you had the formula, it would be H2O. Does that make sense? I hope so. Okay? That's the simplest, easiest way. And Lewis dot works real good for showing covalent bonds because they're sharing. Okay? They aren't transferring. As soon as they transfer, it becomes a little different. Okay? So that's Lewis diagrams and valence electrons. So valence electrons, remember, valence electrons are electrons in the outermost shell. Okay? And if you're having trouble with this, let's try this up here. Let's pick one for example, fluorine. Okay? So fluorine is F, and it has the atomic number 9. Okay? So 9p. I don't know the weight on that one. I need a periodic table. I'll check the weight just to be safe. Its weight is 19. So that means there's 10 neutrons. And that means it would have how many electrons? If there's 9 protons, there's 9 electrons, so there would be 2 and then 7. So what you would do for a Lewis dot for fluorine is put your symbol here, and then you need to fill 7. So you do 1, 2, 3, 4, 5, 6, 7. Okay? That's a Lewis dot diagram. There's a Bohr diagram for fluorine. Okay? And if fluorine, say you have hydrogen fluoride, H with 1 dot, you would have hydrogen